अच्छा, तो बिस्मिल्लाहिर्रहमानिर्रहीम। अच्छा, हम लोग अभी जो पेपर डिस्कस करने जा रहे हैं, दैट पेपर इज बेसिकली फ्रॉम योर क्या कहते हैं इसको, अक्टूबर 2020 का पेपर है, ठीक है। और इसमें कुछ प्रॉब्लम्स जो बच्चों के आए हुए हैं, दैट इज बेसिकली द स्टूडेंट्स फीडबैक अगेन, पेपर 42। And here is a skydiver jumps out of the hot air balloon which is 400 meter above the ground at the time of 30 second। ओके, ये आपके पास इसका इशू नहीं है ऐसे, आपने ये सॉल्व किया हुआ है?
नहीं, मैंने 4-1 तक किया है, 4-2 4-3 नहीं किया।
ओके ओके, मैं बता दूं, ठीक है। देन शी ओपन पैराशूट का सारे का सारा आपको उसने दिया हुआ है, क्या कहते हैं, एक सेटअप दिया हुआ है, ठीक है। और उसके बाद वो आपको बता रहा है कि लेबल द लेटर एक्स इन द पॉइंट वेयर द स्काई डाइवर ओपन द पैराशूट। तो पैराशूट ओपन करने के लिए आपके पास क्या है, दिस इज द पॉइंट वेयर इट इज द पैराशूट इज ओपन एंड लेबल पॉइंट वाई जी 2 पॉइंट्स पैराशूट डाइवर फॉल्स एट द टर्मिनल वेलोसिटी। तो टर्मिनल वेलोसिटी बेसिकली आपके पास ये भी पॉइंट टर्मिनल वेलोसिटी का है और ये भी पॉइंट आपका टर्मिनल वेलोसिटी का, ठीक है। ठीक हो गया, ये पकड़ो। अच्छा, उसके बाद आपका ये आगे चल के उसने डिस्क्राइब इन टर्म्स ऑफ फोर्सेस का क्वेश्चन दिया हुआ है, और डिस्क्राइब इन टर्म्स ऑफ फोर्सेस में आपको ये बता रहा है कि आपने क्या करना है, पैराशूटिस्ट का टर्मिनल वेलोसिटी के ऊपर बात कर रहा है कि टर्मिनल वेलोसिटी क्यों आ रही है। उनको ये बोलना है, ये जो लेफ्ट वाला है, लेफ्ट ये वाला, ये बहुत बड़ा है, ठीक है। ये नंबर जो इसमें लेफ्ट का लगा हुआ है ना, वो इसमें डाल दो, ठीक है।
ठीक है,
और 1 मिनट होल्ड करना बेटा, नहीं स्वैप नहीं करना, ये इसका इसमें शायद आएगा, ये वाला नंबर इसमें डाल दो, नंबर तो नया शीशा लगेगा, और ये पुराने वाला निकाल के रख दे और पुराना मुझे ठीक है। ये तो पहले तो ये शीशा तेज है बच्चे, आंखें बंद करेंगे तो अभी क्या करेंगे, ले जाओ और मेरी बात करा देना। ओके जी, तो ये हमारा सारे का सारा हो गया। उसके बाद डिस्क्राइब द फोर्सेस की फॉर्म में भेज जाओ, ठीक है। उसके बाद आपको उसने बोला है अब हमें कैलकुलेट करना है, कैलकुलेट द एवरेज स्पीड ऑफ द स्काई डाइवर एट द फर्स्ट 4 सेकंड्स के लिए उसने कैलकुलेट करनी है। एवरेज स्पीड के लिए हमेशा ये बात याद रखनी है कि आपके पास टोटल डिस्टेंस डिवाइडेड बाय टोटल टाइम टेकन होता है, ठीक है। टोटल डिस्टेंस डिवाइडेड बाय टाइम टेकन, दिस इज मैंडेटरी। तो आपका टोटल टाइम पता होना जरूरी है। तो व्हेन यू आर गोइंग टू कैलकुलेट टोटल टाइम, टोटल डिस्टेंस आपका वेलोसिटी टाइम ग्राफ से आएगा। कैसे, कितने पहले 40 सेकंड्स का बोल रहा है वो,
हाँ जी,
सॉरी पहले 4 सेकंड, 4 सेकंड में सबसे पहले तो आप एरिया अंडर द ग्राफ निकालो ना यहाँ। तो दैट विल बी 1/2 4 into 40। तो व्हाट विल बी दैट, 80 मीटर्स हो जाएगा डिस्टेंस ट्रेवल्ड, और 80 मीटर 4 सेकंड्स में जा रहा है। तो आप अब करोगे कि टोटल डिस्टेंस इज बेसिकली टोटल डिस्टेंस इज इक्वल्स टू 80 एंड टाइम टेकन इज 4 सेकंड्स। तो आपके पास कितना हो जाएगा सारे का सारा
20।
टाइम, तो इट इज 20 मीटर्स पर सेकंड। अरीवा ने ज्वाइन किया? नो, ओके। उसके बाद क्वेश्चन नंबर,
वो है क्लास में।
okay, उसके बाद क्वेश्चन नंबर 4, दिस इज नॉट इंक्लूडेड इन द सिलेबस, इट हैज बीन एक्सक्लूडेड नाउ। तो इसलिए इसके ऊपर हम लोगों को जरूरत नहीं है थर्मोकपल के ऊपर काम करने की। अच्छा, क्वेश्चन नंबर 6 पे आते हैं। क्वेश्चन नंबर 6 is basically a question which is related to in figure 6.1 आपको बोल रहा है कि आपने क्या करना है, that shows the transverse waves, ठीक है। the transverse waves में the problems are there is not an equilibrium position here। तो आपको equilibrium position को देखना पड़ेगा। तो जो crusts हैं, these are the peaks and these are the troughs। तो करना क्या है, draw a label line to show the amplitude of the wave। amplitude of the wave ये इसने गलत किया हुआ है, amplitude is not that one, amplitude is above the midpoint, ठीक है। आप इसका midpoint मार्क कर लो like this, ठीक है, and then mark the amplitude। so amplitude is above this point, याद रखना amplitude is this one, not the bottom to top, ठीक है। this is amplitude, सही।
Okay, sir.
Wavelength, yes, are you in the class? So this is the wavelength. So wavelength is correct, but amplitude is
Yes,
not.
I'm here.
Okay, then label a trough with a letter T. तो ट्रफ को उसने T से लेटर से एक्सटेंड किया, it is fine. Then a person vibrates, sorry, one end of the string vertically to produce the wave. He makes 15 complete oscillations. How many oscillations? 15 complete oscillations. तो आपको 15 complete oscillations के लिए क्या करना है? 15 oscillations के लिए, ओके सॉरी, 15 complete oscillations के लिए मुझे जाना पड़ेगा, इसके ये बेसिकली नंबर ऑफ ऑसिलेशंस है इन 60 सेकंड्स. तो शो दैट द स्पीड ऑफ द वेव इज 2 मीटर पर सेकंड. तो आपको सबसे पहले ये देखना है कि यू हैव लैम्डा. आपको उसने लैम्डा की वैल्यू आपको दी है, फुल स्केल है, फुल साइज है. तो इसका मतलब ये हो कि यू हैव टू मेजर द डिस्टेंस, राइट. तो पहले आप मुझे वेवलेंथ की वैल्यू मेजर करके दो, ठीक है. उसके बाद फिर हम लोग क्या करते हैं, लैम्डा यहाँ लिख लेते हैं, एंड देन फ्रॉम दिस इक्वेशन आई विल यूज फ्रीक्वेंसी. तो फ्रीक्वेंसी बेसिकली आपके पास क्या होता है, नंबर ऑफ वेव्स डिवाइडेड बाय टाइम टेकन. तो नंबर ऑफ वेव्स, ठीक है, डिवाइडेड बाय टाइम टेकन. तो नंबर ऑफ वेव्स आपके पास कितनी है, 15 divided by 60. So she got this number 0.25 hertz. This is frequency. Calculations करो भाई by using v is equals to f lambda. आप lambda की वैल्यू मेजर करो, plug in the values and then your answer will be there. ठीक है. Is it clear to all?
Sir, so the diagram is up to the scale?
Yeah, it is written. Full scale, full size diagram.
Oh, okay, got it.
Okay. उसके बाद आपके पास आता है, yes, right after that, इसी क्वेश्चन से, इसी से रिलेटेड एक क्वेश्चन है इसका, एंड दैट इज ओह द वेव्स है, वो क्वेश्चन नहीं है, ऑप्टिकल फाइबर का क्वेश्चन है. इन ऑप्टिकल फाइबर, द ऑप्टिकल फाइबर इज मेड अप ऑफ द ग्लास दैट हैज द रिफ्रैक्टिव इंडेक्स ऑफ दिस 1.4. रिफ्रैक्टिव इंडेक्स आपके पास कितना है, दैट इज 1.4. तो आपने रिफ्रैक्टिव इंडेक्स को देख लिया कि दैट इज बेसिकली द वैल्यू ऑफ, यानी वैल्यू ऑफ रिफ्रैक्टिव इंडेक्स 1.4 है. उसके बाद आपको क्या बोल रहा है, स्टेट व्हाट इज मेन बाय did the process that occurs in P to Q. So total internal reflection, or you people can see that light is not coming out, so total internal reflection is taking place. उसके बाद आपको बोला calculate the minimum value of the angle of incidence that is to be, so though no refraction at point P takes place. So इसका मतलब ये हुआ कि आपकी light critical angle पे जानी चाहिए, then it will make all the light into the page, यानी into the fiber. तो जब आपके पास ये आ जाएगा तो आप क्या लिखोगे, दैट क्रिटिकल एंगल इज इक्वल्स टू साइन, यानी साइन सी इज इक्वल टू 1 अपॉन n, ये फार्मूला लगा हुआ है, एंड फ्रॉम हियर शी हैज कैलकुलेटेड दिस, राइट. इज इट क्लियर टू एवरीवन?
Yes. Yes.
State and explain the use of optical fiber in medical. ठीक है, आपके पास 3 नंबर का क्वेश्चन है. तो ऑप्टिकल फाइबर का यूज आपने कैसे करना है, first of all select any area. So let's say we select endoscope, right? Endoscope, gastroscope, these all are basically, हाँ, उसके बाद आपका जो laparoscope है, they all are basically the uses of optical fiber, right? So होता ही है, this is 1 mark, you have scored 1 mark when you have stated this endoscope. अब endoscope work कैसे करता है, you have to write about that the light is sent to the inner surface or organs of the body. ठीक है, स्ट्रक्चर ऑफ बॉडी, वहां से क्या करती है, वाया ऑप्टिकल फाइबर. ठीक है, वाया ऑप्टिकल फाइबर, इट रिफ्लेक्ट्स बैक from the boundary. This all is a procedure. Okay, how does it work? Boundary, and the image is seen by a camera. ओके जी, दिस इज बेसिकली फॉर 3 मार्क्स। क्या आपने आपका कोई भी मेडिकल डिवाइस है तो आपने पहले तो सिलेक्ट करना है कि विच मेडिकल डिवाइस यू आर यूजिंग, और फिर आपने ये देखना है कि हाउ डज इट वर्क। ठीक हो गया? Then the light ray shows 7.1. The monochromatic. So what is mean by state what is mean by monochromatic light? Use one of the following quantities you in your answer: amplitude, brightness, frequency, refractive index, and speed. तो आप ये बता सकते हैं कि मोनोक्रोमेटिक लाइट बेसिकली वो होती है which have same frequency, सेम वेवलेंथ भी कह सकते हो। ठीक है, एम्पलीट्यूड सेम नहीं होता, ब्राइटनेस भी सेम नहीं होती, रिफ्रैक्टिव इंडेक्स भी लाइट का प्रॉपर्टी नहीं है, स्पीड सेम हो सकती है, राइट। Monochromatic basically they are the same type of wave. Once they are same type of waves, so definitely their speed will be same. ठीक है जी? Then this was the question problematic area. That figure 10.1 shows an incomplete electrical circuit. ठीक है, incomplete है, ये तो complete है. Okay, complete अरीबा ने किया हुआ है. Oh, okay, okay. So an emitter is placed here, an emitter is placed here, an emitter is placed here. Yes, 3 emitters आपने place किए हैं. A student completes the circuit to measure the current in the 6 ohm resistor. On figure 10.1, draw the emitters to show the reading on that. तो आपने 6 ohm resistor कहाँ लगा है? Here is the 6 ohm resistor. So it is in the main circuit. So you will draw the emitter in position AB. ठीक है? Clear है? Then a voltmeter is connected to measure the potential difference across 4 ohm resistor. Am I audible? Can I?
Yes, you are.
ओके, सो अब आपको कह रहा है कि एक वोल्ट मीटर आपने कनेक्ट करना है, दैट इज यूज्ड टू मेजर द पोटेंशियल डिफरेंस अक्रॉस 4 ओम रेजिस्टर। तो आप मुझे बताइए कि वेयर इज द 4 ओम रेजिस्टर? यस, सो शी हैज यूज्ड दिस वोल्ट मीटर करेक्टली। वन मोर मार्क। ओके, ऑन फिगर 10.1 ड्रॉ वोल्ट मीटर सिंबल टू कनेक्ट। ओके, ये हो गया आई थिंक सो, connected to measure the potential difference across 4 ohm resistor। 2 marks हो गए आप, क्या बात है। With the circuit components, the current in 2 ohm resistor is 2.5 ampere. Calculate the current in 6 ohm resistor. आपको उसने बोला कि 2 ohm resistor has 2.5 ampere. It means this reading is 2.5 ampere, right? What is the current in 6 ohm resistor? आपने इसमें से करंट फाइंड करना है, 6 ohm resistor में से करंट फाइंड करना है। So there is very technical question. It's really technical question. आपने ये देखना है कि basically once you are dealing with current, so this is 2 ohm resistor and that consists of 2.5 ampere current. So when resistance is doubled, what will be the current in this one? Yes, current would be half. मतलब आपको मैं ये बता दूं कि when resistance is multiplied by 2, current is divided by 2. So what will be the current in this 4 ohm resistor? It will be 1.25 ampere. Am I right?
Yes.
Okay,
Yeah.
now the total current over here, it is added together. So 2.5 को आप क्या कर लो, 1.25 में ऐड कर लो, तो क्या आंसर हो जाएगा? 3.75। ठीक है?
Yeah.
So 2.50 plus 1.25. So total is 3.75 ampere. Next is, yeah, that is done. Oh, great. So first of all, for 4 marks, how will you solve it? Okay, let's say I'm a student and I'm going to solve it. You will say that current in 2 ohm resistor is equals to 2.5 ampere. So current in 4 ohm resistor is equals to 1.25 ampere, because resistance of 4 ohm resistance is twice of resistance of 2 ohm resistor. So the current in 4 ohm resistor will be half of current in 2 ohm resistor. That's it. Is it clear? So you will score all the marks till this point. उसके बाद आपने क्या करना है? You will use that total current in 6 ohm resistor is equals to current in 4 ohm resistor plus current in 2 ohm resistor, so which is basically equals to 2.50 plus 1.25, and that is 3.75 amperes. This value will be written here. Okay, Ji? Is it clear to all?
Yes, sir. Yes.
The next area of discussion is the same year but paper 41. Okay. Okay. Wow, this is a horrible question. For that one, I have to start right from here. Figure 1.1 shows a ice hockey player moving on ice. He's playing, sorry, he's preparing to hit the solid disc called a puck. Okay, the ice hockey player, and he's going to hit this ice, sorry, this ball, this disc. The mass of the puck is what? 0.16 kg. How much mass do we have? Mass कितना है?
0.16.
Yes. And the speed of that is 15 meter per second. Calculate the magnitude of the momentum. आपने momentum calculate करना है. So momentum of the disk is basically m into v. So she has used the correct formula. She has plugged in the correct values, and 2.4 kg meter per second, or you can say 2.4 Newton second. Both will be the correct. अब उसके बाद आपको बोला उसने कि then angle is shown to you. Original direction of travel is this way. This is the original direction of travel of the ice puck, and then you have this direction. Sorry, any question?
Sorry, nothing.
Okay, no problem. The player strikes the disc with a hockey stick, and yes, the momentum of the disc changes. The disc gains a momentum of 3.0 kg meter per second at 45 degree to the original direction of the travel, as shown in the figure. अब उसने आपको क्या बोला हुआ है? State the magnitude of the impulse exerted on the disc. So impulse is what? Impulse is basically, there are two methods to calculate the impulse. एक आपका impulse होता है m into v minus u. Secondly, आप impulse calculate बता सकते हो p2 minus p1, final momentum minus initial momentum. And third, your impulse is basically f into t. Right? Are you getting my point?
Yes.
So, what do we have? That is, the initial momentum is given to you, final momentum is given to you, ठीक है? और बस आप इन दोनों को माइनस कर लीजिए, तो आपके पास कितना हो जाएगा? इनिशियल मोमेंट, फाइनल मोमेंटम कितना है? 3.0 minus 2.4, that will be 0.6 Newton second. And the direction of the impulse is 45 degree to the original direction. ये अरी भाई, ये आपने इसको चेक नहीं किया हुआ, is it correct or incorrect?
I'm pretty sure I had checked this and it said that this was correct.
Okay. So, okay. Yeah, that is fine. This is okay. Yeah, you are right. This is not the final momentum actually. This is a gain in momentum. Oh, exactly. That is fine. So actually, this is change in momentum, or you can say gain in momentum. That is why it would be the same as 3.0. It is not the final momentum, by the way. Sorry for misconception. Okay. So gain in momentum or change in momentum is basically equals to 3.0 kg meter per second. So same is the impulse because momentum has changed. So ये आपका हो गया. अब आपको यहाँ पे आगे बता रहा है determine the magnitude of the new momentum of the disk in the new direction and original direction of the travel by drawing the scale diagram. So how much marks do you have for this question? Okay.
I'm pretty sure this was 7 marks. I think I actually took the picture of this question again. If you go down, I think the page is repeated.
Okay, this is the momentum in one direction, and this is the momentum basically. This is the change in momentum, you can say. The final momentum that was 3, so it is in this direction. So here I have drawn this. So these are two arrows what you have to draw, basically this one and this one. This was your 2.4 and this was your 3.0. So it is simple that 1 centimeter is equals to 1 Newton second, right? That will be 2.4 centimeter line and that will be 3.0 centimeter line. Now you will draw a parallelogram here, and for that parallelogram, what to do? You have to basically go ahead in this way, that from this point to this point, this is a parallelogram and this is a parallelogram. Okay, I have basically I did nothing but just this vector is green. Let me draw it green vector. And okay, so green is green and this purple is here. So where is the purple one? This is the purple one. That is basically the replica I have drawn. Okay, is there any confusion?
No.
So it is again 2.4 centimeter line and it is basically 3.0 centimeter line. So this is basically the head junction. Okay, and this is the tail junction. Tail junction. So you will get a resultant. So Ariba, what will be the direction of the resultant? Can you tell me please? The resultant will be from head to tail, head junction to the tail junction. Actually, how did I do that? Because I was doing on the software, that's why you people would not have this software available in the market. Okay, so I'm gonna erase the first one. Erase the first one. Okay, and here again. Oh no, let's leave it. Okay, देखो हमने क्या किया? I just I just open the compass equal to how much? Equal to 2.4 centimeter, and I put that yani I put that on the head of this larger compass, right? I mean larger vector. Okay, I put it over here. Okay, is it clear?
Yes.
Okay, then I have repeated the procedure and then so on. Just give me a second, please. Okay, sorry. Yes, I was over here at this point. That what to do? I have to open the compass equal to this length. Then I have to place the compass steel point over here, and then I have to mark an arc on that side. Okay, so आप यूँ समझ लें this is an arc from here, and then I will open the compass equal to the length of this green one, this one, and then I will place this, yani green one, I mean this one, huh? This one, and I will open it, or I will place the steel point over here, and then I will mark an arc here exactly at this point, and then I will join them together, and now I got this parallelogram. So I think so parallelogram method is clear to everyone. I'm just going to draw this diagram again for you. I believe so. This is your one vector, any vector. I'm not going to make it at any scale. This is one vector. Okay, ji? It can be any sort of vector. Then we can have, let's say, another vector which is at the head of this one. Suppose this is the vector. Then how to draw a parallelogram? Just open the compass equal to the length of this black one, place it on the head of this one, and then draw an arc here. Almost arc will be over here. Okay, this way. Then at step number 2, open the compass equal to the length of this green one, place it at the head of black one, and mark an arc here. Is it clear to everyone?
Yeah.
Okay, so it
Yes,
means
sir.
the replica of the green will be anywhere here. Actually, I think so. I have not marked the arc properly because I don't have. Yeah, this will be the point. Yeah, this is the point where the arc will be basically interacting with each other. Okay, leave it here, please. Oh, okay, yeah, this is the point. Now it is fine. Okay, so I think so. It would be clear to you. So this is basically the arc. So I'm gonna erase this previous position. This arc is to be erased. Oh, wow. Control Z. Okay, अब चलते हैं आगे. Now you will, yani your arcs are over here. Here were your arcs at this point, and now you will think, or yani you will start. This is the starting point or tail junction, and then the arc point is your head junction. Just join arc point, yani starting point to the ending point, and this is your result. That's it. Is it clear to all? Now what to do? The important thing starts right from here. You have to measure the length of this. Length of this means, for example, if it was 3 centimeter, 1, 2, and 3 centimeter, I will mark the same position 1, 2, 3, and 4, and that side is 5 centimeter. So I can simply say that the resultant momentum will be equal to 5 meter plus 5 kg meter per second. Okay, that can be the scale diagram method. Is it clear?
Yes.
Once you will draw it again, it would be very clear. Okay, so I will request you also to draw this diagram again. Yeah, it was the 4 marks question. Then the next one is explain how. Okay, yeah, this question is something related to a metal container is used to cook the food. The container has a thick wall. Hot cooking oil at the temperature of 120 degrees centigrade is poured into the container. Yeah, the outside surface of the container gets hot. Some thermal energy passes through the metal because the vibrating atoms in the metal collide with the neighboring atom and transfer their energy to them. Explain how the rest of the thermal energy is conducted through the metal container to the outer surface by another process. Yes. So what can be the other process, Mariam?
She's not in the class.
बस उसके बाद तुम बताओगी फिर.
Okay, yeah.
देखो क्वेश्चन समझ आ रहा है. कह रहे हैं कि मेटल कंटेनर है that is used for the cook food. The metal container has a thick wall है उसकी, and hot cooking oil is poured into. आपने उसके अंदर hot cooking oil डाला जिसका 120 डिग्री सेंटीग्रेड टेम्परेचर, आउटसाइड उसकी हीट अप हो रही है. उसने हमें एक चीज बताई है, some thermal energy passes through the metal because vibrating atoms of the metal collide with the neighboring. तो मेटल में कंडक्शन का दूसरा मेथड क्या होता है? Yes, Arifa. Why were you not able to answer this question?
Because like I at first like I couldn't remember, and then when I looked at the marking scheme just confused me even more, because you know they just put straight up blunt points, so it didn't make sense to me.
Okay, what were those blunt points?
It was like the particles are moving and then they hit and then something and something.
Yes, not particle moving. Okay, there is explain how the rest of the thermal energy is conducted through the metal. Conducted through the metal, no other word is used. Metal container to the outside surface by another process. So there are two processes in the metal, that is called free electron diffusion. That's it. Free electrons diffusion. You have to recall this whole process, that the free electrons move from hot part of the container to the cold part, yani from inside to the outside. So along with the vibrating atom, along with vibrating atoms, the electrons get free and they delocalized electrons are free electrons interact with atoms to carry the energy. अब इस पे जाओ जरा, marking scheme पे जाओ and check whether the same points are written in different format or something different is there.
Okay, sir, then just give me a sec. I'll check that out.
Meanwhile, Ida, आप ये वाला question देखो and just frame the answer, please.
Wait, sir, could you just go down a little so I can see the code for the paper?
Okay. Good. हमें यहाँ लिखा है. Yes, it is October 2022, paper 41.
Okay, and the code is 0625, right?
Yes. Yes.
Can you just tell me the question number, sir?
Question number आपने mention ही नहीं किया, तो अब हम क्या कह सकते?
Okay.
आपने picture ही ऐसे लिया. It would be probably question number 6 or 5 या 6 हो सकता है. Okay, one more thing was there. Okay, आप जब तक ढूंढो marking scheme and just tell me what was basically the problematic area but you could not understand from the marking scheme. यहाँ पे ना आप लोग को magnitude दिखा दिया and magnitude के बाद direction भी दिखानी थी, and direction was basically this one. So remember one thing, you will place D here, and once you will place a D, that is actually a sort of आप इसको measure करोगे. This is the angle, this is the direction. This all is measurement question. That's why there is not a big deal here to figure it out. ठीक है जी. Direction यहाँ से आपका angle हो. Okay, did you find it?
I'm trying to. I think I entered the wrong variant. Hold up.
Okay, अब दोबारा देख लेना इसको, फिर मुझे बताना if there is something problem. Okay, कह रहा है the outside surface of the container is brightly polished and shiny. Explain how this reduces the power that needs to be supplied to keep the oil at the correct temperature. Yes. So for this one, this is very interesting. Yani, this is the silvery polished container, and silvery polished container reflects the radiations. And once they reflect the radiation, they are basically the radiation containers, right? The radiation occupiers. So it reduces, you will write in this way, it reduces the rate of energy loss due to radiation. Okay, rate of energy loss due to radiations. Okay, so less power is utilized to contain or to keep the oil at constant temperature. Okay.
Okay, sir. Also, I think the answer that you wrote for the top one was pretty correct because I checked it.
Okay, so what was that? What you were not able to understand? I mean, free movement of electrons or free movement of particles?
The thing where it said vibrating atoms hit free electrons. How do the atoms hit the electrons?
Actually, electrons hit the atoms. I have written the interact with the atoms to carry the energy. Okay.
Okay. Because, like, in the marking scheme, they had said vibrating atoms hit free electrons.
Yeah, the same thing. Actually, the atoms vibrate and electrons move. So those free moving electrons interact with the vibrating atoms. That's why the energy is transferred. This is the second mode of heat trans. I mean, this is the second mean of energy transfer in the metals, the conduction, mode of conduction in the metals. That is why metals are very good conductors. Okay.
Okay.
In part C, okay, part C is fine for you. You have just managed that. The metal container is spherical. The spherical container has smaller surface area than that of the long container of the same volume. Explain the advantage of using this. So yes, so less energy escape, or you can say less evaporation rate or smaller evaporation rate. Okay. Okay. The next part is the current in a 0.10 ampere, the cable from the electrical heater to the plug for the main socket is safe when the current is 20 ampere. Suggest
Okay.
and explain the suitable fuse rating for this. So suggest and explain means if the current is less than 20 ampere, you know, uh, yes, the current in the motor is 0.1 ampere, and the cable from electric heater to the plug is plug for the main socket is basically when the current is less than 20 ampere. जी अस्सलाम वालेकुम सर. हाँ जी. बस खत्म करने लगा था सर. हाँ बस आज ठीक है 5 मिनट दो. ओके. ओके, सो आपको क्या करना है, suitable current, suitable fuse बताना है. So suitable fuse is always greater than, ये आपके सर्किट में लगना है. ठीक है. तो suitable fuse will be greater than this value, 20 एम्पेयर से ग्रेटर होना चाहिए. ये आपकी मोटर का करंट है ना. बात समझ आ रही है?
Yes.
ओके. सो एक्चुअली इसमें आपका जो ये दो करंट देके उसने कंफ्यूज किया, द करंट इन द मोटर इज इतना, मोटर इज वन थिंग, मोटर इज हियर, ओके, एंड द केबल फ्रॉम इलेक्ट्रिक हीटर to the plug for the main socket is safe when there is a current in it is less than 20 ampere. तो आपके पास जो मेन में जा रहा है, if the current it is safe if the current is less than 20 ampere, ठीक है, तो suggest and explain a suitable current rating, तो आपके पास 25 एम्पियर का फ्यूज आप लगा सकती हो, ठीक है, और रीजन मैंने बता दिया कि बिकॉज fuse must have a fuse have a little larger current through it, ठीक है, ठीक हो गया, हमें मेन सॉकेट का फ्यूज देखना है, ना कि हमें मोटर का फ्यूज देखना है, क्लियर है?
Yes.
Yes, sir.
So this was all about your problems. बाकी बच्चों को भी यही रिक्वेस्ट थी कि यू पीपल हैव टू सेंड योर इश्यूज, लेकिन किसी ने नहीं भेजे, तो अब मैं कुछ कह नहीं सकता। इज़ा मेरा बेटा, आपके प्रॉब्लम्स आने हैं, उधार हैं, ठीक है?
जी सही है।
ठीक हो गया, सी यू देन इंशाल्लाह।
See you then, inshallah, sir.
अल्लाह हाफिज़,
अल्लाह हाफिज़।
Allah Hafiz.
हाफिज़।